In previous video, I explained how to vary the brightness of LED using transistor and the potentiometer. And in today's experiment, I'll show you how the intensity is varied. And so when intensity of the LED is varied, what will be the current flowing in the collector and what will be the current in the base? And how it is varied and what will be the different values that I have made one table, and I'm showing you on the right side of the circuit diagram. Now construction of this circuit I'll show you later, how to construct this circuit in Proteus. Now I'll just simulate this experiment and I'll show you the readings, whether we are getting correct readings or not. I'll show you now. And this is 1 kilo ohm pot, and this is 100 kilo ohm fixed resistor. And here you should connect an ammeter. Since it is a base current, you should keep in microampere. And this is collector current, and it should be in milliamp. And here I have connected 470 ohm resistor LED, and just one DC voltmeter between collector and emitter in order to check whether transistor has reached saturation or not. For this purpose, I am using one voltmeter, and the input voltage just I am using 5 volts. I'll show you how much I have used. Go to this and go to edit property. I have set the input voltage at 5 volts. This is DC supply. Now I'll click on simulation. Okay, initially my potentiometer is at 0. At the you can check this here. In the base current is 0 and collector current is also 0. And the voltage between collector and emitter, it is maximum 3.18 volts. Now I'll increase one step. So when I increase one step, it is 3.31 microamps base current is flowing in the base of the transistor, and the collector current is 0.84 milliamps. You check in the table, 3.31 and 0.84. So initially when both are 0, transistor is in off condition, no current flows, because I am not giving any voltage to the base. So transistor will be in off condition. When 3.31 microamps of current is flowing in the base and the transistor goes into the active region and the collector current is increased from 3.31 microamps base current to 0.84 milliamps current. Now I'll increase one more step in the potentiometer. So the potentiometer, when I increased, I'm getting 8.06 microamps. And here the current is 1.99 milliamps. So it is increased. IC is increasing proportionally with IB. Now I'll increase one more step. Just click here. So I got 12.9 microamps and current is 3.08 milliamps. So still the transistor is in active region. When we say the transistor is in active region, there should be a linear relationship between base current and the collector current. As the base current increases, the collector current should linearly, it should increase. Then we say that transistor will be in an active region. Now I'll increase one more step, 17.8 microamps in base current, and collector current is 4.12 milliamps. So still it is in active region transistor because IC is continuously increasing with increase in the IB. So IC is continuously increasing when we increase the IB. So if this happens, this is a linear relationship, then transistor will be in an active region. Now I'll just click on this. It is 22.7 microamps and the collector current is 5.11. So it is reaching its maximum value, collector current. So it is near the boundary of the saturation. So it has not yet reached the saturation, but it is almost near to the saturation region. Now, this reading we will not consider as an active region, but we can consider because it is not completely in a saturation. Now I'll increase one more step, 27.7 for this 5.38. IC increases, slows down. See here, from here to here, 4.1 to 5.11. Here, 5.11 to 5.38. It increased, but in a slow manner. So now the transistor is entering into the saturation because current is not linear here. Now I'll increase one more step. 32.7 microamps and collector current is 5.43. See, 5.38 in the previous reading and 5.43. So now the transistor is completely saturated. IC is almost becoming constant, 5, 5, 5. So IC is becoming constant. When IC becomes constant, we call that transistor is in a saturation region. So now I'll increase further 37.7 microamps of base current. Here I am getting 5.45. So fully saturated. So no more further increase. IC stops increasing. Say 5.43, 5.45. And the last reading I'll get here, 42.7 microamps and current is 5.46. No significant change. So it is reached saturation. This is the final. So I can't increase further because it is fine, and the potentiometer completely rotated to the rotated this side. So this is saturation region, and when both are zero, transistor is in cutoff region. So when collector current is linearly increasing, these readings will be in a active region. So in this way, you can study the readings which I have given, and now I can say that the transistor is acting as a current amplifier. So as and when the base current we are increasing, the collector current, when it is linearly increases, the intensity of the LED also increases. When transistor goes into the saturation, LED brightness remains same. So it won't vary. So that you can observe in the brightness of the LED. At the same time, you can see the voltage between collector and emitter. And when in the beginning I got 3.18, when it is saturated, the voltage between collector and emitter is almost 0.29. It should be 0.2 to 0.3 volts. Then only we say that transistor has reached its saturation. If it is above 0.3 volts, then the transistor will be in active region. You can check here. So 0.29 only, 0.31. See, for 27.7, IC increases slowly. 22.7, I am getting 0.45. For 17.8, I am getting 0.93. It is increased. So when it is increasing, when it is above 0.3 volts, then transistor is in a active region. You just check for 3.31 volts, how much we get? 3.31 microamps. For 3.31 microamps, I am getting 2.5 volts. So when it is 0, I am getting maximum voltage 3.09. So when it is in cutoff region, I'll get maximum voltage between collector and emitter because transistor will be in a off condition. When it is saturated, then I should get minimum voltage, that is 0.2 to 0.3. So I am getting 0.29 volts. So this also you can check. So the same thing, this has done in the Proteus software. The same thing we will do it using a hardware circuit. So that I'll show you in the next video. This is a simulated video. The hardware experiment I'll show you in the next video. You just check in the description box. I have given the link of this in the hardware experiment. In the hardware experiment, I'll give the link of this software experiment. So both, if you watch, you will understand how the transistor acts as a current amplifier. Now I'll show you how to draw this circuit. Open Proteus software, click on new project, and here you can give the name of the project, transistor as an amplifier like that. Okay. So click on next. Keep the design template as a default. Click on next. Do not create PCB layout. Click on next. No firmware project. Click on next. Then click on finish. So after that, you will get this window. Here first you should select the components. I need a transistor. You go to the click on component and click on the search button. Here I want BC107 transistor. BC107 transistor. So this I am getting. You should select the bipolar transistor. Click on this and click on OK. So you just place here. I placed here. Okay. Next, I need one potentiometer. Click on pot. So here we will get, just click on OK. Pot, you should select pot active and click OK and place here. Okay. Next, I need a power supply. Click on terminals, terminal mode, select power and click here. Sorry, not this. I should select DC supply. Here. So click on generator mode, click on DC and paste here. Okay. Next, what we want? We want two fixed resistors. Again, go to component, search here for resistor, type resistor. Okay. So we get this one, resistor. Click on this, click on OK. So one resistor we want near the base. Okay. Another we want in the collector side. You just click here and click on right, rotate in clockwise direction and bring this near the collector side. Okay. So this resistor I want value, click on this and click on edit properties. I want 100 kilo ohm resistor. You just type 100K. Okay. And this resistor value, click on the right click on this, click on edit property. And I want just 470 ohm in order to limit the current for LED, just 470 ohm. Click on this. Okay. 100 kilo ohm and 470 ohm, BC107. And this pot value, I'm click on this, right click on this, edit property. I'm selecting 1 kilo ohm pot. Because if you have 100 kilo ohm pot, you can use 100 kilo ohm pot. No need to use the fixed resistor. If you have 1 kilo ohm resistor, use 1 kilo ohm pot and 100 kilo ohm resistor. Both are one and the same. Next, click on power supply. Right click, edit properties. You make this as 5 volt supply. Just 5 volts. Okay. Now what we need? We need one LED. Search here, LED. Okay. So we get LED. Which LED is selected? LED device, generic LED. click on this, and where we should connect in the collector side. Okay, so it will be in this direction. Again, right click, rotate clockwise. It will come this side and place it here. Okay, next what we need one ground. So select ground and place here. Okay, so now just we have to connect with the wiring. So from power supply, where it should go? Power supply should go to one terminal of the pot, drag and drop here, and other terminal of the pot should be connected to ground, and emitter should be connected to ground, and this resistor should be connected to base, and this pot should be between pot and this resistor we should connect one ammeter here, DC ammeter. How to select the DC ammeter? So you click on instruments, DC ammeter, one you place here. Okay, another one near the collector. So again, right click, rotate clockwise. Okay, next, this ammeter value should be in edit properties. The value should be on microamps. So I'll select 200 microamps. So microamps, how to select? Here it is in amps. You select microamps. Click on OK. And this multimeter, you should, this is 200 milliamps. So you make it milliamps and click OK. Okay. Now you just connect it, wiring, and click drag and drop here, and this here, and from cathode to here, and register is already connected, and from anode to power supply positive. Okay, next one DC voltmeter I should connect. Click on DC voltmeter. Okay, one should be connected to collector, and there should be connected to ammeter. Okay, so this is all about what should be the reading here. So I'll set this at 5 volts or 20 volts, whatever, 20 volts I'll set. Okay, now this is ready. You just click on the simulation. So we will get the readings what I have explained now. So this is all about the current amplifier using BC107 transistor. So in BC107 transistor, the beta should be varying from 200 to 300. The beta value ranges from 100 to 300. If you calculate the beta value using the formula IC by IB, if it is within this range, then you should understand you are getting the correct readings.